Okay, good day, grade 11s. I hope you are all well and healthy. We started with analytical geometry on Thursday. Now there's only two problems that I still want to discuss, and then we're going to carry on with inclination angle. Now, example 6 of last week was determine the equations of the straight lines passing through the points. Okay, now the first one, they've given you 2 points. So if I start with number A, the first thing that you need to calculate is the gradient. So the gradient between these 2 points, you remember gradient is y minus y over x minus x. So I'm going to say 9 minus 3 over, if I started with a 9, I must start with a 1. 1 minus 2. 9 minus 3 is 6. 1 minus 2 is 3. So the gradient is 2. Now, I can use any of the two equations, y equals mx plus c, or y minus y1 equals mx minus x1. I'm going to use the second one. Now, you can choose any of the 2 points. It really doesn't matter. You are going to get the same equation because both points are on the line. So, if I choose the second point, then it's y minus the y value equals gradient is 2x minus the x value. And I simplify, that gives me 2x minus 2 here. And if I take the minus 9 and I add it to the right-hand side, I get 2x minus 2 plus 9 will give me plus 7. Okay. Now, if we go to number B, I actually want you to see something. Through the points minus 1, 3 and 7, 3, can you see that the y coordinates are the same? If I sketch it for you, minus 1 and 3 will be somewhere there, minus 1, 3, and 7, 3 will be somewhere there. And if I draw a line through those 2 points, what can you see? What do you see? Can you see it's a horizontal line? And can you remember what we said last week? A horizontal line has an equation, y equals where it goes through the y-axis, where it passes the y-axis. So the equation will simply be y equals 3. If you didn't see it, and you calculated the gradient, and you said y minus y over x minus x, can you see what you get? 0 over 8. And 0 divided by anything is still 0. So that tells you it's a horizontal line. And if you want to use the equation, y equals mx plus c, or this one, doesn't matter which one you use, the gradient is 0. Doesn't matter which point I use. Say I use this point. If I substitute x with minus 1, x with minus 1 and y with 3, can you see what you get? That gives me a 0. So c is equal to 3. So my equation will just be y equals 3. But can you see how much faster you can get it if you just look at what the sum gives you? Okay. If you look at number C, it's the same situation. The points minus 2, minus 1, if I draw it, where's minus 2, minus 1? It's more or less there. And minus 2, 5? Minus 2, 5 is there. Can you see? Minus 2, minus 1, minus 2, 5. And if I draw a line through those points, can you see that I get a vertical line? And can you remember what the equation of a vertical line is? It's just x equals where it passes through the x-axis. If you didn't see it and you wanted to calculate the gradient, look what happens. Y minus y over x minus x. Now you get a 6 over 0, which is undefined. And can you remember we said an undefined gradient means a vertical line. And what's the equation of a vertical line? X equals where it cuts the x-axis. So if you can see that you have a horizontal line like in B or a vertical line like in C, you don't even have to do any calculations. You just write the equation straight away. Okay. And then the last one that I want to do from Thursday, they've given you the equations of 2x minus 3y equals minus 4 and x plus 2y equals 5. They've shown it to you on a sketch. They've given you the equations there, and they ask you to calculate the coordinates of the point P. Now, what is P? P is the intersecting point. Now, how do you get the coordinates of any intersecting point? Now, it doesn't matter if it's two straight lines that intersect, or a parabola and a straight line, or a hyperbola and a straight line, or a hyperbola and a quadratic equation. It does not matter. If they ask you any intersecting point, then you must know I'm going to do simultaneous equations. That's the method. You must learn recipes. So what I call methods are recipes. So if they ask you intersecting point of two different graphs, you are going to solve simultaneously, simultaneous equations. So if I take my first equation, that's 2x minus 3y equals minus 4. And I take the second equation, x plus 2y equals 5. The easiest method is to get the equation where you can get x or y alone. The easiest. Now, can you see from this equation, you can get x alone very easily. So, x equals minus 2y plus 5. I just take the 2y to the right-hand side. Now, I can call this equation 1. And I can call this equation 2, and I'm going to say I'm going to substitute equation 2 into equation 1. Now, you know that maths is a neat subject. So write neatly, do your work neatly, tell the examiner what you're doing, because then it's easier for you to get marks. So I'm going to take equation 2 and I'm going to put it into equation 1. That means x equals, so where I see an x, in my first equation, I'm going to substitute that x with minus 2y plus 5. So there's my equation. 2 times, in the place of x, I write minus 2y plus 5. Then there's minus 3y equals minus 4. And now I just have one unknown. I have a y and a y unknown, so I can solve. So that gives me minus 4y plus 10 minus 3y equals minus 4. Here I can add the y's. So that's minus 7y equals, just mute your mics, please. And then I can take this 10 to the other side. I get minus 4 minus 10, which will give me minus 14. If I divide the minus 7 away, then I get y equals 2. So now I have the y coordinate. And can you see if I substitute this in 2 again, then immediately I have x. So I'm going to substitute that into equation number 2. Then I get x equals minus 2 times, in the place of y, I write a 2 plus 5. That gives me minus 4 plus 5. That gives me a 1. So therefore, my point P, which is the intersecting point, is the point x is 1 and y is 2. So that intersecting point will be 1 and 2. So if you want to find any intersecting point between two graphs, that's what you do. So you started with simultaneous equations in grade 8, I think. So what did you actually do? You didn't realize it. But what you did was you had two straight lines. They intersect somewhere, and you're calculating the coordinates of the intersecting point. Okay, now that was actually revision of grade 10 analytical geometry. Now we carry on to the grade 12 analytical geometry, and that is a new word that you must learn, and that's the word inclination. Now, let me first explain what is inclination. Inclination is the size of the angle between the positive x-axis and the line that you have. So if you look at this sketch, this first sketch, the size of the angle between the x-axis and the line, that angle there is your inclination. We call it the inclination. Okay. If you go to the second sketch, now here you have a line with a positive gradient. It's an uphill line, you remember from last week. Can you see that this line here, the second one, is a downhill line? So this line has a negative gradient. Negative gradient. I chose -1 here. What is inclination? The angle between the x-axis and the line. Now, the thing that's very important is that it must be a positive angle. So inclination is always positive. That's the first thing that you must remember. Inclination is always a positive angle. Now, if you have a gradient that's positive, then your inclination or your inclination angle will be an acute angle. If your line has a negative gradient, downhill line, then your inclination will be an obtuse angle. Now, I hope that you have your calculators in front of you, because how do we get inclination? To get inclination, you need the gradient. You need the gradient. So to find the inclination, you must remember inclination is always positive, and you need the gradient of the line. Now the formula is tan of the inclination angle is equal to the gradient of that line. So either you will have the gradient or you will have the inclination angle. So yeah, if you look at the first one, I gave you m is equal to 1. The gradient is equal to 1. So how will I get the inclination? I'm going to say tan of the inclination is equal to the gradient. And the gradient in this case is 1. Now, can you remember how you get gradient, how you get rid of tan? You say theta is equal to shift tan of 1, like we did last week with the general solutions. And what do you get when you say shift tan 1? You get 45 degrees. So that angle there is 45 degrees. For a positive gradient, your inclination will be an acute angle, and there you see 45 is an acute angle. If you have a negative gradient, your inclination will be an obtuse angle. Now let's see. Tan of, there's my inclination, tan of theta is equal to, in this case, minus 1. Now if you say shift tan minus 1, then the calculator gives you minus 45 degrees. And I said inclination is always positive, always positive. So what does your calculator give you? Your calculator gives you the smallest angle, whether it's positive or negative. So what your calculator is giving you is that angle there. So if you remember, we said that's the positive direction of measuring, that's the negative direction of measuring. So this minus 45 actually means that angle there. And that's not what you want. You want the angle above the x-axis. So how will you get this theta? You just add 180 degrees, angles on a straight line, angles on a straight line. So if this angle that your calculator gives you as minus 45, then you just add 180 and you get 135. And can you remember I said, if you have a negative gradient, your inclination will be an obtuse angle, in other words, bigger than 90 degrees. So that's the new grade 11 work. Now we will practice that. I just want to refresh your minds. Let's see if I can just take this a little bit out of the way. If I show you that blue horizontal line, can you remember we said a horizontal line has a gradient of 0. A horizontal line has a gradient of 0. So what's the inclination? What's the angle between the x-axis and that line? Well, this line is parallel to the x-axis. So the inclination is 0 degrees. If you look at the vertical line, and I ask you the inclination of this green line, you remember from last time and from what I did here, can you remember I showed you here the vertical line? The vertical line here has an undefined gradient. Vertical line has an undefined gradient. So if you have a vertical line, the gradient is undefined. But what is the inclination? The inclination is the angle between the x-axis and the line, and what's the size of that angle? It's 90 degrees. So remember that a horizontal line has a gradient of 0 and an inclination of 0 degrees. A vertical line has an undefined gradient and an inclination of 90 degrees. Okay. How can they ask it to you? The first one they say, find the inclination of the line 2y plus 3x equals 5, round off to 2 decimal places. Now, Can you remember what we said is inclination? For inclination, you need the gradient. And then you say shift tan to get the inclination. So first of all, I must find the gradient. So how do I find the gradient of a given line? I must first have the equation in standard form. That means y equals mx plus c. Because if I have y alone, then m is the gradient. So the first thing that we must do is we must take this equation and we must get it in standard form. So 2y plus 3x equals 5. So 2y is equal to minus 3x plus 5. If I divide this 2 away, I divide the 2 away, I divide the 2 away. What am I interested in? In the gradient. So now to find the inclination, I say tan of the inclination is equal to the gradient. And to get rid of tan, I say shift tan. Now can you see that's a negative gradient, and we said with a negative gradient, your calculator is going to give you a negative answer, and then you have to add 180. Let's see if it works like that. If I say shift tan minus 3 over 2, shift tan of minus 3 over 2, I get an answer of minus 56,309. You get it? You get that? But that's not what I want. I don't want a negative answer because inclination is positive. So I must add 180 because my calculator gave me the negative answer. And if you add 180 and you round off to 2 decimals, you're going to get 132,69. And we said if there's a negative gradient, you will have an obtuse angle. That means between 90 and 180, and there you see it is true. So for number 1, they gave you the equation and they asked the inclination. Let's see what they ask for number 2. Find the equation of the line with inclination 135 degrees through the point 32. Now, they gave you the inclination. Find the equation of, so you need y equals mx plus c, or y minus y1 equals mx minus x1. So, and you have only 1 point. But doesn't this inclination have something to do with the gradient? Yes, I know that tan of the inclination is equal to the gradient. And now if you type tan 135 on your calculator, you get the gradient is minus 1. So now you just substitute the minus 1 into the gradient and the point that they're giving you into the place of x and y, and you can find the equation. So y is 2, the gradient is minus 1, the x coordinate is 3, and you can calculate c. And that will give you a c value of 2 plus 3 is 5. So your equation is y equals, your gradient was minus 1x, your y-intercept was 5, and there you have your equation. Whether you write it like that or whether you write minus x plus 5, that really doesn't matter. So in the 2 cases here, the first one, the gradient was given and you had to find the inclination. The second one, the inclination was given, and you had to find the equation. Okay, what else? How else will they ask it? Ooh, inclination between two lines. Now that actually looks terrible. What they want is the angle between the two lines. Now what you must realize is you must first draw an x-axis. And where do you draw the x-axis? Through that intersecting point, that point of intersection. You draw an x-axis through the point of intersection. Okay. Because, now can you see you have two equations? If you can find the inclination of this line, I'm going to call it alpha, and you can find the inclination of that line, I'm going to call it beta. Can you see that theta is just the difference between the blue and the purple angle, beta minus alpha? So do you agree that I can say theta is equal to beta minus alpha? And alpha and beta is just the inclinations. So I have the equation, and you know by now that there is the gradient. The gradient is in front of the x. So the gradient of this line is 1. So I can say tan of alpha is equal to the gradient of that line is 1. And if I say shift tan of 1, then I get an inclination of 45 degrees. So this small angle here, this purple one, is 45 degrees. But I can do the same for the other line. This beta is the inclination for that line. And you know that there's the gradient of that line. So now I can say tan of beta is equal to the gradient is 2. And if you say shift tan 2, you are going to get that angle beta as 63,43 degrees. So this big angle, this blue angle here is 63,43. So I calculate the inclinations of the two lines first. And then I'm just going to subtract. So theta 63,43 minus alpha, I calculated as 45. And if I subtract that, I get 18,43 degrees. So that's another way of asking something about inclination. Let's see how else can I ask it. Find the angle between the y-axis and the line. And they are talking about this blue angle here. So let's call it theta. But now remember, inclination has nothing to do with the y-axis. So if you need an angle that's not against the x-axis, it means you need to find an inclination in some way to be able to calculate the angle that's not against the x-axis. Now, the only thing that you have is 2 points on that line. Now, if you have 2 points, you know that you can calculate the gradient. And if you have the gradient, you can find the inclination. Now, this point here is the point 0 and 3. And this point here has coordinates 2 and 0. So if I want the gradient, I must say y minus y over x minus x. So it's 3 minus 0 over 0 minus 2. So that gives me an inclination of 3 over minus 2 or minus 3 over 2. It's a negative gradient. Yes, I have a downhill line. So let's call this angle here. Let's call that angle there alpha. That's the inclination. So I can say tan of the inclination angle is equal to the gradient. And that's the same as what we at now. If you say shift tan minus 3 over 2, you get minus 56,309. This is this angle here. But if you add 180 to get the positive obtuse angle there, you get 123,69 again. Now, will that help you to find this angle theta? Yes, you can work in one of two different ways. You know that between the x-axis and the y-axis, y is? Ask again. Y is? Why are we calculating this angle? Okay, you're breaking up terribly. Just let me explain. Perhaps I answer your question. I can't hear what you're asking. Why do we calculate this inclination angle? Because you know that that angle between the x-axis and the y-axis is 90 degrees. And now I can work with either exterior angle of a triangle is equal to the sum of the opposite interior angles. You remember? Exterior angle of a triangle, I have this now. There's a 90-degree angle. I want that angle, but I have this angle is 123,69. Now you can either say exterior angle is equal to the sum of the opposite interior angles. So exterior angle is equal to theta plus 90 degrees. And then if I want theta alone, I must just subtract that 90 degrees. And that gives me a 33,69 degrees. So that's how the inclination will help me to find the angle against the y-axis. Or you can say, okay, I can work with angles on a straight line if I don't want to work with exterior angle of a triangle. Then I can work with angles on a straight line. This angle here, angles on a straight line, will give me 56,31 angles on a straight line. And then I can work with some angles of a triangle, interior angles of a triangle. So 90 plus theta plus this one, 56,31, must give me 180 degrees, interior angles of a triangle. Now, whether you do what I did here for exterior angle of a triangle, or whether you say theta plus 90 plus this 56,31 is equal to 180 degrees, that's some angles of a triangle or interior angles of a triangle, you are in any case still going to get 33,69 degrees. So inclination helps you to solve other angles, even if they are not inclination angles, but it helps you to solve other angles, just like in this example here, where you had to minus two inclination angles to get the angle between the two lines. Okay, so that's how inclination can help you. Okay, let's do another one.
Excuse me, ma'am.
Yes.
How many marks would this be?
Okay, you will get a mark for calculating the gradient first. Then you will get another mark for minus 56, and then probably because you added the 180 to get the inclination angle. And then you will get another mark for calculating the correct angle. So 1, 2, 3, 4, 4, 5 marks. If they want to, more or less 5 marks, 4, 5 marks. Depending on what information they give you. Now, if you look at this one, you will see it's, I will show you, it's going to count more marks because it's a more complicated sum. There you see 3 lines. I've only given you the equation of one line. Okay, I've given you a 90-degree angle there, which you will see now will help you. But now look what they ask you. They ask you an angle, yeah, that's not even close to the X or the Y axis. So you must make plans. Now, okay, can you see that there you have a triangle? There, luckily, you have a 90-degree angle. So, okay, one angle is given. Now, to find beta, you first have to find this angle here. Okay. So now you can do 2 different ways. Can you see that because you have the inclination of line AC, you can calculate this angle here. Let's call this angle here theta. Just that green one there. Just that green one there. And you see that you can calculate that because that is simply the inclination of line AC. And you have the gradient of AC. So I'm going to start there. So the gradient of AC is equal to 1. That was given. So tan of that green angle theta is equal to shift tan 1. Tan theta is equal to the gradient. So by now you know that shift tan 1 is equal to 45 degrees. So that green angle there is 45 degrees. But that's not enough to find beta. You still need this angle here. To find this angle here, you can calculate if you have the gradient of line AB. But now the problem is you have one point on line AB, and it looks like that's all that you have. But is that really all that you have? What is A? Now you must think further. What is A? A is an x-intercept of that line. And for x-intercept, make y0. So for line AC, can you see this sketch is now more complicated, so it will count more marks. So for line AC, A is the x-intercept. And for x-intercept, make y0. So I must take the equation y equals x plus 3, and I must make the y0. So that will give me an x of minus 3. So now I know this point here is minus 3. So can you see now, I must first calculate the gradient of AB. So now I can find the gradient of AB this point has coordinates minus 3, 0, and this point has coordinates 0 and minus 1. So gradient y minus y over x minus x. So 0 minus 1 over minus 3 minus 0. So that gives me a gradient of negative 1 over 3. It is a downhill line, so it must have a negative gradient. So can you see that's more work, so more marks. So now if I say tan, let's make this angle alpha. Tan of alpha is equal to minus 1 over 3. So alpha is shift tan minus a third. And if you say shift tan minus a third, you get minus 18,43 degrees. Now, can you remember what I said about that minus 18,43? It's the angle between the x-axis, the smallest angle. So that angle is minus 18,43. But what's the size of that angle? Isn't the size of this angle alpha just 18,43? Because if I now add 180 again, I get that angle there, and that's not really what I want. So do you agree that I can work with this 18,43? The size, now remember a length is always positive. The size of an angle is always positive. The plus or the minus just gives you the direction. So if I can say this angle is 18,43, the size, I know it's the negative direction, but the size is 18,43. Can you see that now you can calculate beta? So now I can calculate beta, because beta plus theta plus alpha plus this 90 degrees must give me 180 degrees, because interior angles of triangle, or some angles of a triangle. I have theta because I calculated it. I have alpha because I calculated it. So now I can calculate beta by saying 180 minus 90 minus theta, which is 45, minus alpha, which is 18,43. And then if you calculate that, you get an answer of 26,57 degrees. Now, this is a lot of work, so it will count much more. So you will get a mark for the 45. Then you will get a mark for calculating the gradient. Then you will get a mark for calculating that angle there. Then you will get a mark for calculating with some interior angles of a triangle. 1, 2, 3, 4, 5. Well, you can even get a mark for knowing that that's the x-intercept. So this sum can count 5, 6 marks easily. So it depends on the difficulty of the sum. Okay, but that's how they can ask inclinations. Okay, then there's one more thing. You must know the difference. It's new vocabulary again, between median, altitude, and perpendicular bisector. So it's words. If you don't know the meaning of the words, then you cannot do anything because you don't know what they're asking you. Now, what is median? Median, if they ask you find the equation of the median, they will ask you from vertex. Now, you know what is a vertex. A vertex is just one of the points. There's a vertex, there's a vertex, there's a vertex. So median is a line from a vertex to the midpoint, so you must have the vertex, to the midpoint of the opposite side. So if I can show it here, if I want the median from A, then it's from that point to the midpoint of the opposite side. So it's that point, say that is the point M, which is the midpoint. So now the first thing is you must first find the midpoints, and you must know the formula. X plus x divided by 2, y plus y divided by 2. So you have to find the midpoint of this side, and then you're going to calculate the equation through A and M. We will do an example just now. So that's what median is. So for median, you need to calculate the midpoint of the opposite side. And then from that vertex to the opposite side's midpoint, you are going to find the equation of the line. What does the word altitude mean? It's again from the vertex, so you must know from where do you want the altitude. So you want it from that vertex again to the opposite side, again to the opposite side, but now it means perpendicular to the opposite side. So what do you do now? You are first going to get the gradient of this line. Say this is ABC. Then you are going to get the gradient of BC, and then you are going to get the gradient of this vertical line. So if you have the gradient of BC, you're going to find the gradient of the vertical line. And you know it's minus the inverse. That's what we did on Thursday. So then you will have the gradient of this perpendicular line. You will have 1 point. So you're going to calculate the gradient of the perpendicular line. You have the vertex, and you're going to find the equation because you have the gradient and the 1 point. And then the last one is perpendicular bisector. Now just think what the word means. Bisector means you divide a line in half. Bisect. Bisect means divide in half. So you want a perpendicular bisector of AB. So you want the midpoint of AB. So you need the midpoint of the line where you want the perpendicular bisector of. And what does perpendicular mean? Well, perpendicular means perpendicular. So through the, where you divided the line in half, through the midpoint, okay, you must get a line perpendicular to AB. So what do you need? You need to calculate the midpoint first with a formula. Then you're going to calculate the gradient of AB again. And then you must know the gradient of the perpendicular line minus the inverse. Okay, so if I can show you an example, I can give you something like that. Triangle ABC, the coordinates of the three vertices are given. Find the equation of. Now number A says the median from B. So what did we say? From that vertex, median means to the midpoint of the opposite side. To the midpoint of the opposite side. So that means I must first find the midpoint. So for A, I must find the midpoint of AC. Can you remember the formula for midpoint? X plus X So it's x plus x divided by 2 and y plus y plus minus 3 divided by 2. That gives me 2 divided by 2 is 1 and minus 2 divided by 2 is negative 1. So this midpoint is 1 and minus 1. And now I want the equation through B and M. So the next thing that I must calculate is the gradient of BM. Gradient is y minus y over x minus x. So 5 minus 1 over 2 minus 1, which gives me a gradient of 6 over 1, which is 6. And now I can use my equation. I'm somewhere going to use y minus y1 again. Y minus y1 again equals mx minus x1. And remember, it doesn't matter which one you use, y equals mx plus c or that one, it will give you the same answer. So don't worry about that. So y stays y. Now you can choose. You can choose this point, 1 minus 1, or that point. Doesn't matter because both are on that line. I'm going to take that point for in case I made a mistake here. So y minus 5 equals gradient is 6. X minus, and the x coordinate of b is 2. So that gives me 6x minus 12. And if I take this minus 5 to the other side, it becomes plus 5 minus 12 plus 5 is minus 7. And there's the equation of the median. The second question is altitude. Okay, now it means from B, I must draw a perpendicular line to AC. A perpendicular line to AC. So, can you remember we said we must first now find the gradient of AC. So now I'm going to find the gradient of AC first, which is y minus y. So y is 1 minus y is minus 3 over x is minus 4 minus x is 6. That will give me 4 over negative 10 or negative 2 over 5. But that's the gradient of AC. So the gradient of this line is negative 2 over 5. So what's the gradient of the perpendicular line? The gradient of the perpendicular line is then positive, the inverse. In other words, 5 over 2, because the one times the other one must give me an answer of minus 1. So the next thing now I say the gradient of the perpendicular line, which is the altitude, will be positive 5 over 2. Now I have only this point. I have only this point, so I cannot use another point. So y minus 5 equals 5 over 2 x minus 2. And if I simplify that, I get 5 over 2x. 5 over 2 times negative 2 gives me minus 5. And if I take this minus 5 to the other side, it gives me a minus 5 plus 5, and it falls away. And my equation is 5 over 2x. So there's the equation of the altitude. And now the last question is the perpendicular bisector of AC. Now remember what we said. Bisector means we divide that line AC in half. So in other words, we need the midpoint of that line. We need the midpoint of this line. Now we have it already. We calculated that already. So there it is. Now we need a perpendicular line through that point. Perpendicular line through that point. Okay. Now didn't we calculate the gradient already? Gradient is 5 over 2. Because the gradient of AC is negative 2 over 5. So a perpendicular line will have a gradient of positive 5 over 2. So I have done most of the work already. So if I carry on here with number C, I have the gradient already. The gradient of the perpendicular line, I calculated it now, is 5 over 2. The midpoint, I calculated it already, was 1 and minus 1. So I have the gradient and I have a point, and I can say, okay, y minus, now I only have this point to use. I don't have another point, so I must use it. Y minus minus 1 equals, gradient is 5 over 2 x minus, and this one is 1. I simplify, I get 5 over 2x. 5 over 2 times minus 1 is minus 5 over 2. Here I have y plus 1. If I take this one to the other side, I get 5 over 2x minus 5 over 2 minus another one is minus 7 over 2. And that's the equation of the perpendicular bisector. So it is not difficult if you know the meanings of the words and what to do. If you don't know the meanings of the words, then you will also not be able to do anything. Okay, so this is more about vocabulary. Okay, I'm going to stop there for today. And then tomorrow I'm going to start with functions. Functions is another word for graphs. So I'm going to do parabola, hyperbola, exponential graph, to find the equations to get the graphs, the sketches. So I will do that Tuesday, Wednesday, Thursday. I will do functions. Okay, enjoy the rest of your day. Keep well, and then see you tomorrow again. Bye-bye.
Bye.